In this little exercise, we're going to look at finding the angle between two triangles or two surfaces. So there can be more than three sides on the surface. But if you have two surfaces and you want to find the angle between them, say for example you take a sheet of paper and you fold it randomly in half, not exactly in half, but just randomly anywhere, fold it over. If you wanted to find out what that angle is when it opened up a little bit, you would be looking at what's called the dihedral angle. And you do that by looking down along the fold line, just like we're after doing on the last question where we looked down along the true length. We found the true length of a line and then we looked along the length of that true length. So we start off by finding the two surfaces, and we've got two triangles here, one of them ABC and one of them CBD, and the same in elevation. One of them is blue and one of them is green. So the nearest one to us is the green one, and then the blue one is slightly behind in the elevation. So our line of intersection is CB. So what we're going to be doing is we're going to be trying to look at right angles to that in the plan. Now it can actually work either way, but we're going to look at right angles to it in the plan, and then we're going to look along it. So the first thing I do is I set up my x1, y1 at parallel to CB. And I'm looking at right angles to CB. That's what that arrow is indicating there. And I'm going to project out all the points. And I'm going to take the height of each of those points from the elevation. And then I'm going to join those up and label them. And then I'm going to look along the line C2, B2, because that's a true length. I've looked at right angles to CB in the plan. Therefore, C2, B2 is a true length. I can now look along that line for my second auxiliary view. And then my x1, y1 goes at right angles to that. I project down all the points, and I take my distances back from the x1, y1 back. So the distance back to CB is the same because it's a parallel line. Therefore, C3, B3 becomes a point. And that angle that's generated between the two, so I've got ABC and I've got CBD as an edge view of both of those triangles, and that's the dihedral angle in between them.